Beneath the icy surface of Siberia lies a hidden danger. As the permafrost melts, it unleashes climate risks that reach far beyond the Arctic and deep into our global future. Permafrost is ground that remains frozen at or below 0 degrees Celsius for at least 2 years. Permafrost isn't just ice, it's a mix of soil, rocks, ice, and even organic matters such as ancient plants and animal remains. Did you know that Siberia hosts one of the largest continuous permafrost in the world, with a thickness that could reach up to 5,410 feet deep, making it a prime location for permafrost observations and research. For thousands of years, the permafrost in Siberia has played a crucial role in regulating Earth's climate by storing vast amounts of greenhouse gases such as methane and carbon dioxide. One of the early signs of this phenomenon appeared in the 1950s when scientists began noticing surface changes in the tundra. A dramatic example is the formation of Batagaika crater, also known as the gateway to the underworld, which is a massive crater that began expanding in the 1990s and is now the world's largest permafrost crater. These images from 1999, 2016, and recent years show how dramatically it has grown due to continuous permafrost thaw. By the 2000s, the thawing had become more rapid and visible, with infrastructure like roads, buildings, and pipelines in Siberian towns starting to crack. Not to mention the 2020 heatwave in Siberia, with recorded temperature of 38 degrees Celsius, the highest ever recorded there, has melted the permafrost deeper and faster than usual. In Siberia, the local effects of permafrost thaw are already visible. Buildings, roads, and pipelines are cracking and collapsing as the once solid ground beneath them softens. In some areas, massive sinkholes and landslides are forming, changing the landscape entirely. But the impact doesn't stop there. As the permafrost melts, it releases greenhouse gases like methane and carbon dioxide, accelerating climate change. This creates a feedback loop. More warming causes more thawing, which leads to even more emission. On a global scale, this means rising temperatures, sea level rise, and even the risk of ancient pathogens resurfacing, like the anthrax outbreak in Siberia in 2016, which was believed to come from an anthrax-infected reindeer that was preserved in ice for decades. For Asia, the consequences include more frequent and intense floods, droughts, and coastal threats due to rising seas, reminding us that what happened in Siberia doesn't just stay in Siberia. To slow the thawing of permafrost, scientists and engineers are turning to a mix of modern technology and nature-based solutions. In Russia, scientists are monitoring permafrost conditions using satellite data and ground sensors to track changes in temperature and ground stability. Engineering solutions are also being applied, such as building structures on raised platforms or using special cooling systems to keep the ground frozen beneath important infrastructure. Some researchers are even exploring innovative ideas like restoring ancient grasslands to reflect more sunlight and cool the ground, which inspired from Pleistocene Park. Thawing permafrost may seem like a distant problem, but its effects are global and growing. what melts in Siberia doesn't just stay in Siberia. It fuels climate change, raise sea levels, and disrupt life across the world, including here in Asia. If we don't act now, the ground we stand on, literally and globally, will keep slipping away.